Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in 8086 microprocessor. We're going to see different types of interrupts. In previous video, I have very clearly explained about the interrupt operation. What is the normal interrupt operation in 8086? What is interrupt vector table? And what is the basic different types of interrupts? Right? I would recommend you to go through that video first before coming to this video, because that is the very basic of 8086 interrupt operation. Only if you understand that particular concept, you can able to easily understand the different types of interrupts. So in this video, we will see different types of interrupts. Whenever we say different types of interrupts in 8086, it can be hardware interrupts and software interrupts. When we say hardware interrupts, there is only two interrupts. One is maskable interrupt and non-maskable interrupt. A non-maskable interrupt is NMI interrupt and maskable interrupt is INTR interrupt, right? And we already seen what is software interrupt. When it is software interrupt, it's nothing but it's from 0 to 255, right? And totally there will be 256 software interrupts, okay? And here, when it comes to maskable and non-maskable, you have to understand what is maskable, what is non-maskable, and what is vectored interrupt and what is non-vectored interrupt. Vectored interrupt, non-vectored interrupt, right? Whenever we say a vectored interrupt, what is a vectored interrupt? Any interrupt which has a address, specified address, just predefined address, then that is called as vector address. Say for example, in the previous video I have explained for how the interrupt have its own address location, 4-byte address. Each and every interrupt 0 to interrupt 256 has its own address locations, right? So all those interrupts are called as vectored interrupts. So if there is a specified address, then that is called as vectored interrupts. And whenever there is no specified address, right? No specified address, then that is called as non-vectored interrupt, which means the processor has to calculate or has to find out the address location of that particular interrupt and then it has to serve. So it will take some time, right? That is the difference between vectored and non-vectored interrupt. Similarly, what is maskable interrupt and what is non-maskable interrupt, right? So when we say non-maskable interrupt, right? Non-maskable interrupt, we can able to we cannot able to control that particular interrupt, right? That is, you will not be able to disable that particular interrupt. That is, for example, the microprocessor has its own decision to serve the interrupt or not, right? Say for example, if there is a maskable interrupt, right? Whenever it executes a main program, there is a non-maskable interrupt. Then the microprocessor can decide whether I can able to serve this interrupt, I need to serve this interrupt or not, right? So if it decides it need not to serve this interrupt, right? Then it will complete this execution and only then it come here, right? That is called as maskable interrupt. Whereas maskable is it can able to control that particular interrupt. Non-maskable, it will not be able to control. As soon as that interrupt comes, it will stop this execution and it will serve that particular interrupt. That is called as non-maskable interrupt, right? And we know that in 8086 architecture itself, we have INTR interrupt, and we have NMI interrupt. NMI is non-maskable interrupt and INTR is maskable interrupt, right? So both are hardware interrupts, but this cannot be controlled and this can be controlled. And I have explained already, this interrupt will be served only if IF flag is equal to 1, right? Only the IF flag is 1, even though there is an interrupt, there happens an interrupt, right? Only if IF flag is equal to 1, it will be served. If it is 0, it will mask it. That is why it is called as maskable interrupt. Right? Now you understand what is hardware interrupt, what is software interrupt, what is vectored interrupt, what is non-vectored interrupt, what is maskable interrupt and what is non-maskable interrupt, right? So whatever I said just now, right? So interrupts can be split into hardware, software and maskable and non-maskable interrupt. So any program, right? Any program that halts the main program, right? Any instruction or any method that is going to create a halting process for the main program, that is called as interrupt, right? So what is interrupt subroutine? Interrupt subroutine is nothing but after the interrupt, the microprocessor will go to the location of that interrupt and it will serve that particular program. That is called as ISR, interrupt service routine or interrupt subroutine, right? And as I said, we have two hardware interrupts. One is maskable and non-maskable. INTR, this 18 pin, that is maskable interrupt, and the 17 pin NMI is non-maskable interrupt, right? And both are hardware interrupts. And we also know that INTR, we have INTR-A. You have INTR-A, that is to help this INTR. That's because the microprocessor, whenever the NMI creates an interrupt, the microprocessor immediately will serve that particular interrupt because it has a particular address. It is of highest priority, so it will have its own address location. But whenever there is an interrupt in INTR, microprocessor will not be served immediately because it has to find out the address location or the exact location where the interrupt will be, right? So it will take some time. That is the difference between the NMI and the INTR interrupt, right? So you can see here, hardware interrupt is nothing but any particular device, any particular peripheral device can able to connect with the processor, right? That is what we call it as hardware interrupt by using these two pins, that is NMI and as well as INTR pin. And as I said, NMI is non-maskable interrupt and it is of higher priority. We can also call it as type 2 interrupt. And whenever the NMI interrupt is going to happen, remember in previous video I have said whenever interrupt happens, these steps will be followed, right? Whatever interrupt, the same steps will be followed. You can see it will complete the current execution in progress, and then it pushes the flag register and then pushes the CS and IP of the main program address, right? And then the IP and CS of the ISR, right? The ISR will be loaded. You can see the ISR address, that is 008 here. Why? Because it is 008 because it is type 2 interrupt, right? NMI is type 2 interrupt, so it is 008, right? And similarly the CS part will be 000A, right? And then what it will do is it will also reset the interrupt flag and trap flag. The same steps will be followed. Only one difference is depending upon the interrupt, this memory location will be varied, right? And as I said in NMI, like NMI will happen only if it is free from ground. If it is connected to the ground, then there is no interrupt, right? And whenever there is a reset, it is removed from ground, then the NMI interrupt will happen, right? And what are the conditions to NMI to happen? During power failure, during critical response time, non-recoverable hardware errors, watchdog interrupt, and memory parity errors. In all this condition, non-maskable interrupt will happen. And whenever non-maskable interrupt will happen, it will go to the 8 location. It will serve that particular interrupt subroutine and come back, right? And what is INTR interrupt? As I said, INTR interrupt is a maskable interrupt. Why is that I say maskable interrupt? It will be served only if IF flag is set. It will be set, right? That is, you can see here, only when IF flag is set, it will be served. If it is 0, then it will not be served. So you can able to control, the processor can able to control this INTR interrupt, right? And here it will not be able to find out the address location immediately because it does not have a specified address location like NMI. So what microprocessor will do, it will seek the help of INTR-A, right? What it will do is whenever there is a INTR interrupt happens, the microprocessor will send 2 pulses, right? 2 pulses. Why it sends 2 pulses? The first pulse, the 2 pulses to the INTR-A pin, right? INTA pin. What is INTA pin? That is interrupt acknowledge pin, right? So it says 2 pulses. 1 pulse, it will tell the external device to be ready, and in next pulse, it will receive data from that particular device, right? So that is the operation of INTR interrupt, right? So even that is also a hardware interrupt, right? So you can see that the same. It will be the same steps that will be followed. It starts the current execution, right, and activates the INTA, receives the interrupt type, right, and flag register CS value and IP value pushed it, and similarly the ISR. Once it finds out the location, after finding out that location, right, that will be, say for X, that will be multiplied 4. That content will be loaded in IP and CS, and similarly the interrupt flag and trap flag will be set. I have already explained why we are resetting this interrupt flag and trap flag, right? Because we are already serving the interrupt. So if the interrupt flag is again enabled, then it will again an interrupt will be created. So to avoid that, these two flags is reset. Clear, right? And we already seen software interrupts. I'll explain again. Software interrupts is the desired interrupts, that is a programmer can create an interrupt, right, based upon the address location. Say for example, I've said an interrupt based upon the interrupt number, we can able to find out the address location. So from 0 to 256, we can able to find out the address locations of any interrupts, any types, right? Any interrupt type. Say for example, if it is 32, it is 32, then 32 into 4, that is the address location of interrupt 32, right? Similarly, if it is 24, 24 into 4, that is the address location of the interrupt 24, right? So the software interrupt from 0 to 255, sorry, 0 to 255, so totally it will be 256 interrupts, right? In this 256, we have already seen how it has been separated. It is separated into three categories. 0 to 4, it is dedicated interrupt, and 5 to 31, it is reserved interrupt, and from 32 to 255, it is user defined interrupts, right? And for all those interrupts, it is the same steps. The flag register has to be pushed to the stack, and CS value of the return address and IP value of the return address, that is the address of the next instruction, that is pushed to the stack. Similarly, the address of the ISR, CS and IP, that is loaded to the processor, right? And similarly, the interrupt flag will be set and reset. This is the execution type for all the software interrupts, right? And as I said, the first 0 to 4 is a dedicated interrupts, right? We have explained all this already in previous video, but this is the software interrupt, that is 0 to 4 dedicated interrupt, which is whenever there is a particular condition that is going to happen, right? Say for example, any particular special conditions. For example, in division, if you're going to divide by 0, then it will create infinite quotient, right? So in that condition, it will not be able to save. It will not be able to save the infinite value. So it will create type 0 interrupt. And type 1 interrupt, whenever the IF flag, the trap flag is equal to 1, right? It will initiate the type 1 interrupt, right? That is, in that, when this interrupt is created, it will go for single step execution. And type 2 interrupt is nothing but non-maskable interrupt, and type 3 is breakpoint interrupt. I already said what is breakpoint interrupt. In breakpoint interrupt, whenever there is a very big program, right, we will not be able to check the logical issues of the complete program at the end, so we can create a breakpoints then and there, and we can able to check the logical issues. That is called as breakpoint interrupt, right? By using type 3 interrupt, we can create breakpoints. And similarly, whenever there is overflow, then that is called as type 4 interrupt, right? Whenever there is overflow, it will create a type 4 interrupt, right? And 5 to 31, it is called as reserved interrupt. It is used for higher processor, and for from 32 to 255, it is used for software interrupt. And for all these interrupts, it will be the same steps that is going to be followed. For example, break 3 interrupt. I have already explained what is break 3 interrupt, right? And for break 3 interrupt also, you can see it is going to be the same steps. That is, the flag register, it is going to be pushed to the stack. And similarly, the CS value and IP value of the next address of the next instruction, it will be loaded into the stack. The IP and CS of the ISR will be loaded here. Since here it is type 3, so it is 3 into 4, right? That is the memory location in hexadecimal, right? And also it will reset the interrupt flag and trap flag, right? And similarly, type 4 interrupt, that is interrupt overflow, that is no whenever there is an overflow flag is enabled, then this interrupt will happen, right? Even here, this whenever this interrupt happens, it is going to be the same steps. Since it is a type 4 interrupt, so it is 4 into 4. This is the address location. Apart from it, everything is same. You can see it pushes the flag register. It will push us the CS and IP value of the next instruction. It will load the CS and IP value of ISR, and then it will reset the interrupt flag and trap flag, right? So it will be the same steps, whatever interrupt that is going to happen, right? So basically you have to understand what is the interrupt operation, right? How the interrupt operation is executed in 8086. If you understand that concept and interrupt vector table concept, definitely you can able to explain any interrupts very easily, right? So today what we have seen is, we have seen what are the different types of interrupts in 8086. We have seen what is hardware interrupts, what is software interrupts, and what are the different types of interrupts, right? I believe this video will be very useful for you. Thank you, my dear students.